Hello, Mr. Ryan, are you right?
I guess so.
Okay. So you still remember SQL, right? Structured Query Language, which is the language, the standard scripting language we use to query the database. So it's structured query language. Okay? Remember that select t-shirt from closet where color is red, right? Remember that basically the select, insert, update, delete. Yeah, we talked about that a long time ago. So we given a table, right, with two columns, N and P. Both are integer. Look at these, right? These are the headers. Okay? These are two columns. Okay? Look at this. The N and P. The N is the values. The P is also the value. So what does it mean? Look, the node. This is the node. This P representing the parent. What's the data structure if I give you this? We have a node, and then we also specify, we also give the parent of it. So what kind of data structure can you think about that, based on this table? A node and a parent. A node with a parent. So what is this? What kind of data structure satisfy this?
Tree.
Tree, yes, because with a node and a parent. Well done, okay? Okay. So look, the node and then the parent. Okay, and then if it doesn't have a parent, we put a null. What's null? What's the meaning of null? It means empty, none. Basically, it's none, the same thing, okay? Okay, so why there's a none for the node 5? What happened? Why the 5 is special with none?
Because it's 2 and 8.
No. Why the parent of what is the meaning of none here? The parent. The parent of 5 is nothing. So what does it mean?
Is it a child?
So in the tree, you just said in the tree.
The parents died.
The parents. So
No, he fell off the tree. He's the root.
root. Yes, that's the root. Okay. So let's draw this picture. Okay. So let's see.
The tree.
It could be a binary tree or it could be multiple, it could be a tree. It doesn't have to be a binary tree. But let's draw this to see what kind of tree is this, okay?
Binary tree.
So the 1, the parent is 2.
Binary tree.
3, the parent is 2. 6, the parent is 8. 9, the parent is 8. So we don't know where is 8, okay? So 8, we have a kid. 6, we have a kid 9, right? And 2, the parent is 5. 8 parent is 5. So 5 has 2 kids, 2 and 8. Okay. So 5 have a parent of 2 and 8. Okay. So 5 have a parent 2 and 8. And 5 doesn't have any parent. So 5 is the root, right? This is a tree, right? A binary tree. Okay. Yeah. Okay, so we can represent a binary tree using this, right? We can specify the node and its parent. And parent,
Dad,
yes?
2 is the parent of 5.
2 is the parent of 5. No.
2 is the parent of 1, 3, and 5. No, he just drew it wrong.
Okay, you mentioned a very good point. Yes, because tree is a graph, right? And then you can visualize this, but it's basically directed a cyclic graph, right? Because we just said the parent of 2 is 5. So it's like that, right? So it's actually have a direction, okay? So this 5 is a loop. Alright. So we want to query, right? We want to query to make it this. So node and type. Okay. So L stands for leaf node. In for inner. Okay. Basically, R stands for root. Okay. So basically, we want to use the SQL select to query the type of it based on this information. So how can we judge from this table that what type of the node it is? There are only 3 types of node: the root, the leaves, and the rest, which is inner. Okay. So
91.
okay, can we drop it? Okay. So you just said the parent. The node with no parent is the root. Okay, and how about the leaf node? How do we know if it's a leaf node?
If it doesn't have any descendants.
If it doesn't have any descendants, okay? Then how about the inner node? It has a parent, right? It has a parent. So basically, how do we check if the type of node it is? So first of all, we check if the node has a parent. If it doesn't have any parent, it's a root node. And then we also check if it's the parent of the somebody else, then we call it inner node. Otherwise, it's a leaf node. Am I right?
Yeah.
It's easy to check if it's a root node. And how about the inner? How about the inner node and the leaf node?
If it has.
The inner node is how do we check if 2 is an inner node? How do we check if 2 is an inner node based on this? Based on this P.
Because there's twice.
Because 2 is somebody else's parent. So it's an inner node, right? How about this 8? How do we check? We just check if it's the parent of somebody else. Alright? Okay? So how about
You never know, it might be the root.
that's good. We check the first thing is to check if it's a root.
Then why can't we look up the nodes?
So first of all, we exclude the root because root is very simple. We just look at this, and if it's null, then it's a root node. Okay? Then if it's not, because there's only one root node, and then the rest we just check if it's in the P, if it's somebody else's parent. If it's somebody else's parent, it's a inner node. Otherwise, it's what?
Leaf.
Yes, simple. Okay.
Not that simple.
Yeah. Okay. So how can we write
People
that?
wouldn't know what you're doing.
Yeah, that's true. Yeah. So this is kind of like a decision tree, right? So decision tree. What's decision tree? We want to make a decision. Okay. So something like that, right? Okay. We're here. That's the star. Right? If the parent is null, then if yes, then that's a root. We end. If not, right? If not, then we check. If it appears in a P, if it's somebody's
It's
parent,
hot.
then if
hot.
yes,
It's hot.
okay, if yes, then we say it's an inner root. Otherwise, it's a leaf node. Okay? Yeah. So look, decision tree. Alright, sit down.
It's hot.
What kind of example? What?
You spat on me.
Okay, sorry. Can you sit down a bit?
But it's hot.
Can you give me an example of how do we apply the decision tree? In the morning, you go to school, right?
Yeah.
You check the temperature. If it's more than 20 degrees.
I think we learned about that before.
Yeah.
Wait. Can I get something and check something?
Okay.
I can get what it's called.
Yeah.
It's hot. I think it's good flowchart.
Flowchart. Yeah, similar. Okay, come back. Similar. Yeah. Very good. Thank you for mentioning that. Okay. Okay. So yeah, decision tree. So I give you an example of decision tree. Please. I give you an example of decision tree. Okay. If it's Thursday, right? If it's Thursday for you, then you bring the packed lunch. Okay? And if it's
No, only every day.
okay, every other week. Okay.
Most days.
For you, right? If it's Monday, you bring your cello. Simple. That's a decision.
No,
tree.
but if orchestra is cancelled, then he doesn't bring cello.
Okay, yeah. Then you can put as many branches as you need, right? This is decision tree. Okay, this is actually one simple strategy of the artificial intelligence, right? AI does that as well. Okay. Okay, so let's write an SQL code. Remember, let's select things. Select teacher from, right? This is the basic format of SQL. Select query. Select teacher from crosses where color equals red and it's clean, right? And it's clean, not dirty. Okay. So let's write this. And we want to sort it this by the node, right? This is in sorting order. So let's write this.
What?
So there are a couple ways to write this query.
Ha!
Okay, let's write it in a very simple way, and we're going to talk about the rest in the next lesson. Select the n, right? Because look, this result is 2 columns. We want to select n, okay? And also, then we need to check, right? We can use the if statement, if function. If what? If p is null, then we return root, right? Okay. So this function takes the 3 parameters. The Boolean condition when it's evaluated true, comma, when it's evaluated false. This if function has 3 parameters. The first parameter is the boolean, the condition to check, right? If p is null. If it is, then that's the value. We return the root. Okay? Okay, if it's false, then what happens if it's false? We have to check. If it's false, we have to check this, right? We check if it's somebody else's parent, okay? So then we can wrap it with another if, right? If then we can say if this n is in somebody's p, right? So if n in select p from this tree, okay? From this tree. Right? If this is in that, then it's a inner node. Otherwise, it's a leaf node, right? Okay, select if this statement, and then from tree, and then order by n. Okay, order by n, which means that we want to sort the result, return the result by the node. Okay, make sense? If p is null, then it's a root node. Otherwise, we check if this n, if this value, right? For example, like 2. If it's somebody else's parent, if n in, how do we check if it's somebody else's parent? So we check this value. If it's in the p, right? In this set, in this column, then if it is, then return the inner node. Otherwise, return the leaf node. Okay, right? And then return this result. We want to sort it by the n. Okay, so that's one way. Another way we can use the match. The case statement. So basically we can replace this if, right? This if, because this if has the nested if statement, we can say case. Okay, select case. This is a keyword. Select case. So what? When p is null, then root. Okay, look, this is simple, right? And then when n in, this is the same, right? Select p in from the tree. Select p from tree. Then inner. Okay, else leaf. Yeah, is leaf better? Clear. There are 3 cases. Case when p is null, then the root. When n is in p, when n is somebody's parent, then inner. Else, this is other cases, leaf. Yeah, make sense? Okay, it's simple, right? This is SQL select statement, right? We learned about the if function and the case function, and we also talk about the binary tree. So what have you learned today?
Different ways of representing a binary tree.
And how do we check? Yeah, we want to judge the type of the node by looking this table, right? This is relation table. So how do we check if it's a node is a leaf node?
So we just use like process of elimination.
Process of elimination. Yeah, that's the word. Yeah, that's very good. So process of elimination. So first elimination is the
root.
Yeah, if it's not the root, then we check if it's in. If it's, what does this mean? N in select p from. This is the sub query, right? Select p from the same table here, right? And then we want to check if n is in that. What does it mean? What does it mean? We want to check if n is in there. What does it mean?
If it's like in the column of p.
What does it actually mean?
It means that if it's like
somebody else.
parent.
Yeah, if it's somebody else's parent, then it's an inner node, right? It can't be a leaf node, right?
Yeah.
And it can't be the root node because we eliminate the root in the first place, okay? And otherwise, it's a leaf node, okay? Yeah, simple, right? Look, we have a subquery of querying with the same table, okay? So basically, we can use the join, okay? I'll talk about the join later, right? Remember, in the feature, right? Look at this. What's this? What does it remind you of this?
Venn diagram.
Yeah, Venn diagram, yes. So this is a table, this is another table, A and table B. So there are different ways of join. Inner join, here. Left join, here. Right join, here. And then outer join. Okay, so different ways of joining. Okay, and then there's also the cross join. Yeah. Okay, so we talk about that in the next lesson. Okay, that's it for today. Bye bye. Bye.
Bye.
Good.